Okay, so this part we're going to do the quadratics formula. So the first thing it says, find the value of the discriminant. So that's how we've been working out all of these. We've been finding the discriminant first. And remember, the discriminant is the b squared, I'll write it in blue, b squared minus 4 times a times c. And the quadratic formula states x equals negative b plus or minus the square root of the discriminant, the stuff that we just found. So I'm just going to put discrim all over to a. So here we go. So on the first one, let's go ahead and determine what our a, what our b, and what our c are. So a equals 1, b equals negative 2, c equals negative 16. And we know that because it is ax squared plus bx plus c equals 0. So that's how we determine what the a is the understood 1, the negative 2 is the b, and the negative 16 is the c. So now we find a discriminant. So we say negative b squared minus 4 times a times c. So now we use our calculator. We get 4, and then we do negative 4. Clear out my calculator. Negative 4 times 1 times negative 16 gives us a positive 64. So now we know that 64 plus 4 is going to give us a 68. Now, so we found the discriminant, and it says to determine or describe the number and types of solutions. So because this is a positive number, then it's going to have to be 2 real roots. So the discriminant is 68, and the type of roots is 2 real roots. So now it says determine the roots, and that's when we use the quadratic formula. So we have x equals negative b, so negative b, so negative b is negative 2 plus or minus the square root of the discriminant. Well, this is our discriminant, so it goes right here. So 68 all over 2 times a, and a is 1. So now we solve. X equals positive 2 plus or minus the square root of 68 all over 2. Now let's break down 68. So let's see what we can break down 68 into. Square root of 4 and square root of 17. Let me make sure that that's right. 4 times 17 gives me 68. So the square root of 4 is 2, and you can't break down 17 anymore, so it's just going to be square root of 17. So we have x equals 2 plus or minus 2 root 17 all over 2. Now we need to simplify. Well, we can simplify if all 3 of these numbers can be divisible by the same thing. And they can. All of them can be divisible by 2. So then when we simplify this, 2 divided by 2 is 1. And you must have that 1 there. It doesn't work if you don't have that 1. Plus or minus, because then it assumes that it's 0. And it's not 0, it's 1. Square root of 17, because 2 divided by 2 is 1, all over 1. But we don't need to put that all over 1 because it's not necessary. So our roots here are x, and then brackets, 1 plus or minus the square root of 17. And there you go. So the discriminant, I'm going to rewrite this a little bit smaller. Discriminant is 68 and 2 real roots. Okay, next, 26. So this was not set up right because it doesn't have equals 0. So we need to get everything over to the left side, and so the right side will equal 0. So we get x plus 3x squared plus 3 equals 0. Well, we're still not in the correct order because it's not in descending order. So we need a to go first. So if we go 3x squared plus x plus 3 equals 0, we're on the right track. Now we can determine what A is, what B is, what C is. So A is 3, B is 1, and C is 3. So now let's determine our discriminant. So we've got 1 squared minus 4 times A times C. So we get 1 minus, let's see what 4 times 3 times 3 is. That is 36. Minus 1 is going to give us a negative 35. So at this point, we can go ahead and say what the discriminant is. Discriminant is negative 35. And what type of roots? Well, because it's a negative number, we're going to have two imaginary roots. Now we need to figure out the exact roots or the solutions. So let's work this problem out. So I'm just going to write it over here. So if we have x is equal to the opposite of b, so negative b, so we have a negative 6. What's b? B is 1. So, sorry, looking at the wrong problem. Okay, b is 1. So we have a negative 1 plus or minus the square root of our discriminant. Well, our discriminant, we've already said, was negative 35 all over 2 times a, and a is negative 3. So we've got x equals negative 1 plus or minus, well, let's break down 35. So if we break down negative 35, we have a negative 1 and we have a 35. Well, we know that square root of negative 1 is I. And I don't believe that there's any perfect squares in 35. 5 and 7, and then that doesn't break down anyway. So then we would have I square root 35 all over negative 6. So we cannot simplify in the terms of none of these. We'll divide by one number, but we're good mathematicians, so we do not want to have a negative in the denominator. So we're going to multiply everything by a negative 1. So that just changes all the signs. So we get x is equal to a positive 1 plus or minus. Doesn't change I, because all it does is going to change that positive to a negative, which is that, and then the negative to the positive, which is just that. So we don't even need to change the I. Square root of 35 all over positive 6. So those are your roots for this problem. So x equals 1 plus or minus I square root of 35 all over 6. All right. Flip over. Here we go. 2 more quadratics. So it's already nice and in the right order. So let's determine our A, our B, and our C. A is 1, B is negative 6, C is 9. So the discriminant is negative 6 squared minus 4 times 1 times 9. So we get 36 minus 36. And that gives us a 0. So our discriminant is 0. So what does that mean our types of solutions are? Well, hopefully you'll say one real. Now let's go determine what that real is, that one real. So we get x is equal to opposite of negative 6, so negative b, so negative times a negative 6, plus or minus the square root of 0 all over 2 times 1. So here we go. X is equal to, well, this right here gives us a positive 6. And then plus or minus, well, what's the square root of 0? 0 all over 2. Well, what happens when we add 0 to 6, or 6 plus 0, we get 0. 6 minus 6, 6 plus 0 is 6. 6 minus 0 is 6, so we don't even need that right there. So we could say that x is equal to 6 halves, which equals down to 1. 3. 6 divided by 2 is 3. So our one real root is x equals 3. Okay. So here we go. We only have 2 terms here. So we have a, which is 4, but we don't have a b term. So we would have a is equal to 4, b is equal to 0, and c is equal to 81. So when we define the discriminant, it's b squared, so it's, just work it out, 0 squared minus 4 times a times c. So you get 0 minus, what's 4 times 4 times 4 times 81? Well, my calculator. I got 1296, 1,296. So 0 minus that is going to give me a negative 1,296. So here's my discriminant, 1,296. And then because it's a negative, that means I'm going to have 2 imaginary roots. So let's figure out what those roots are. We have x is equal to a negative b, so it's minus 0, plus or minus, which does nothing. The square root of negative 1,296 all over 2 times 4. So you get x is equal to, well, we can leave that off because that does nothing, but a placeholder. We have plus or minus, let's see. So the square root of 1,296 is 36. So we have a negative 1, square root of negative 1, which is I, and the square root of, I'll rewrite this, the square root of 1296 is 36. So we get 36I all over 8. Now we can simplify right here. 36 divided by 8, if you do that in your calculator, you're going to get plus or minus 9 over 2, so 9 halves I. And that gives us 2 imaginary roots. So x equals plus or minus, so there's your 2, 9 halves I. All right. Now let's go through these last couple words, writing of roots. These are the last thing we did. So remember, we're going to work backwards this time. Instead of factoring, we're going to go ahead and we're given the roots and we need to get them into the equation. So the first step, we're going to go one step at a time right here, is we say x is equal to 2, x is equal to 7. We're going to start skipping steps in a minute. And then from there, you want to get each side equal to 0. So you have to subtract over your 2, and then you have to subtract over your 7. Now we can write these as binomials. Sorry, lost track here. So you can have x minus 2 times x minus 7 equals 0. And now we FOIL. So we get x squared minus 7x minus 2x plus 14 equals 0. Combine like terms. So x squared minus 9x plus 14 equals 0 is your answer. Okay, hopefully that made sense. So now let's look at 30. So we're going to go kind of faster where we're just going to go straight down to the binomial times the binomial. So x, and we've got to do opposite of what's in here, so it'd be positive 1/2. And then x minus 5/4. Now remember how we said the easiest way is to bump this in front of your x. Bump the denominator in front of your x. And mathematically that works because you're really just multiplying everything by this denominator. And then you're multiplying everything to the 4. In this binomial, you're multiplying everything by 4. And then it ends up working out the same. We kind of explained that in class. So you get 2x plus 1. And then you get 4x minus 5 equals 0. And then from here, we're going to FOIL. So when we FOIL, we get 8x squared plus, let's see, negative 10x plus 4x minus 5 equals 0. And now combine like terms. So we get 8x squared minus 6x minus 5 equals 0. And then that is our answer. Okay, 2 more quickly. Now this is the Algebra 2 part. These are where it has the i's in it. So again, we have our binomial squared, our binomial times a binomial. And we're going to have a plus 8i, and we're going to have a minus 8i. Remember, imaginary numbers come in pairs. So now we FOIL. FOIL. So x times x is x squared. X times negative 8ix is negative, x times negative 8i is negative 8ix. And then 8i times x is a positive 8i. And then positive 8i times a negative 8i. Please don't forget to multiply those 8s because a lot of times you guys are telling me it's a negative 8i squared, and it's not. Don't forget to multiply by these 8s. So it's negative 64i squared is equal to 0. So let's combine like terms. What happens here? Well, they cancel out. And then what happens here on this I squared? We've got to change that to a negative 1. So we get x squared minus 64 times negative 1 equals 0. So we get x squared plus 64 equals 0. And this is now a SATS problem, which we don't have to factor. We are done. Okay, last one. So we will have an x plus 2/3 I and an x minus 2/3 I. And now we FOIL. So you get x squared plus or minus 2/3 ix plus 2/3 ix. And then we get a, oh, I wouldn't have done it this way. Let me redo this one. Let's erase. I would have brought it up so I wouldn't have had fractions because then I don't have to deal with fractions. I could have done it this way. I'd get the same answer, but then I would have to multiply it, and then it kind of seems ugly. So let's start over. Plus 2/3 I, x minus 2/3 I. Okay, so now right here, bump up. Bump it up. Bump it up. Okay, so we get 3/4 plus 2i. That looks so much better. 3x minus 2i. And now we FOIL. So now it makes it a little bit easier so we don't have to deal with those fractions. So we get, okay, so 3x times 3x is going to give me 9x squared. 3x times a negative 2i is going to give me a negative 6xi. 2i times 3x is going to give me a positive 6xi. And a 2i times a negative 2i is going to give me a negative 4i squared equals 0. Combined like terms, the middle terms right here are going to end up canceling out. And then we're going to deal with this I squared. So we get 9x squared minus 4 times negative 1 is equal to 0. So 9x squared plus 4 equals 0. And we are done. All right, guys, I hope this helps to have done every single one of these problems for you. I hope you watch it, and I will see you tomorrow. Good luck.